All right, folks, welcome to your Stat 1300 Fall Final Exam Review video/videos. This is video one of a few, most likely. Today, we are brought to you by special in-house sponsors, Cliff Bar Holiday Edition Spice Pumpkin Pie, tasty Cliff Shots, energy blocks, yum, 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 and this lovely gluten-free cereal that I just buy, which might go to a lucky winner. If any of you spots a mistake, might get this if it's not eaten by Monday. So we'll find out. Folks, if we did this one in all classes, add up the total of number of students in this graduate program. There's 85, and then take 27 divided by 85, 19 divided by 85, and so forth. Make that lovely pie charts. The 5-number summary, you got to put them in order, least to greatest. Because I have 15 numbers, I do, sorry here, working on that angle, I do have a true middle at 87, at 8th one. That means I'm going to eliminate that kind of from the count. This would be the first 7, so the middle one, 84, is my quartile 1. This is the next 7, the middle 197 is my quartile 3. You know what the min is and the max. That's my 5-number summary. This is my box plots. All right, 1.5 times the interquartile range, which is Q3 minus Q1, that's 13. 1.5 times that is 19.5. Subtract that from quartile 1, add that to quartile 2. If you have any number outside that range of 64.5 to 116.5, you have an outlier. We have no outliers here. All right. Moving on to the next page, folks. Number 3, definitely you want to use the old calculadora. Please do not do this by hand. Those are the steps. You are going to hit calc. We'll do it right here. We're going to hit calc. Gosh darn it, we're working here. Gonna hit stats button. You're going to hit edit, and you're going to type in your numbers. This one has a different problem here. You're going to type in all your numbers. And then you would hit stat calc 1 var stats. Again, you're going to have different numbers. What you care about is x bar and s. X is the sample standard deviation. You're going to write those down. That would be your answer. Okay? Build an interval of the mean minus 2 standard deviations to the mean plus 2 standard deviations, which we got here. And first off, obviously you can't have a negative amount of sick days. So it's basically like 0 to 24.5. An outlier would be 32 because it's outside that interval. Here, folks, make a stem plot. We have a score in the 30s. We have a few in the 40s. 50s are represented, 60s, 70s, 80s, 90, and you have 100. Yes, you put them in order. That question is not hard. Just take your time. You have 90 minutes for, I believe, 29 questions. Plenty of time for your final on Monday. Both classes final on Monday. Please take your time. This is an easy question. All right, folks, so this one is by hand. I do have the formula sheet ready for you. X bar, simply add them up, divide by 6. That's your sample size. What you do is you take each individual number in your data set and subtract the mean, and then square it, your squared deviations. You do that for all 6 of them, then you sum them together. Then you divide by n minus 1. We want our variance there to be an unbiased estimator. Then you take the square root of your variance to get your standard deviation. I will give you this formula here. Z is x minus mu over standard deviation if your data is from a normal distribution. The m stands for mu, and that's your population mean. X is your person you're looking at, that individual, so that number in question, that score in question. And then sigma is your standard deviation. Folks, you need to look that up, and I am not prepared on your Z table. Here we go, folks. You look up 0.31 on your Z table. 0.31 you see has 0.6217 is that number. That is the area to the left. Remember, your Z-score gives you the area to the left of that Z-score, okay? So because you want greater than, you got to do 1 minus that Z-score value, all right? Folks, for the next one here, calculate your Z-score. Remember, you always round your Z-score to the nearest hundredth. Your Z table is given to you in hundredths. Then you look up negative 0.63, 2643, I believe. And because I want to be less than that, that is exactly what my answer is, 2643. Then lastly, we get the point. You look up a Z-score of 1.25. Because I want to be greater than that, I do 1 minus that. Next one here, folks, is just have two scores. If I want to be between, I look up for negative 0.11. That's the area to the left of it. Yogi barking at a phantom postal worker there. Relax, buddy. For your Z-score of 0.81, area to the left of that would be right here. If I want to find the area between those two Z-scores, I would subtract. That's probability of getting a score between 500 and 600 on the SAT math. Folks, what we do next, looking at correlation. The three weakest or strongest would be the ones closest to, that have an absolute value closest to 1. And the three weakest would be the ones with an absolute value closest to 0. All right, if I give you the coefficient of determination, r squared, to find r, just take the square root of that. The slope is going to have the same sign as your correlation coefficient. So if slope is negative, your r is also negative. Okay, these are also very easy questions. Which must have the strongest r value? Strongest r value. The one with the highest r squared value. All right. An easy question as well. And take your time, folks. I give you a linear regression equation. Least squares regression equation, same thing. The slope is negative 1.83. The y-intercept is 92.27. Folks, notice it says interpret what they both mean. So basically, every class you miss, your grade's going to go down by 1.83 points. If you miss 0 days of school, you get a 92.27. That represents sort of the highest grade here. We know there's always some issues with the y-intercepts. Predict the score, y hats, plug 8 in for x. You should get a 77.63 if you miss 8 days of school. Find the residual. I will do that format as y minus y hats. In fact, I should have written that one right there. It's what you actually get minus your predicted score. Plug 6 in. So folks, don't get confused. That's your x value. Plug 6 in for x. You should have gotten an 81.29 based upon historical data. You actually got an 88. You overperformed by 6.71. If you want to earn at least an 80, plug it in for y hats, solve for x, little algebra 1. You should not miss more than 6 days. Round that down always. Who would have the largest residual? A person with 3 days and a 90, 3 days missed and a 97, or a person who missed 12 days but earned a 78. For the person with the 97, plug 3 in for days missed. They should have earned an 86.78. So their actual minus their predicted, they overperformed by 10. Person that missed 12 days, plug 12 in for x. They should have gotten a 70.31. They overperformed by 7.69. Now what I mean by largest is the largest, you know, the one furthest from 0. So if this would have been a negative 10.22, that would have also been the winner. That residual is the furthest from 0. All right, so that's what I mean for this question. Not necessarily who overperformed the best, but who had the largest performance away from their predicted performance. All right, folks, take a look for this. Now I'm going to show you the next one. I have that already entered. You're going to go to Stat Edits and list 1, put team runs. That's your Y value. That's your Y value, team runs. List 2, batting average. Don't forget about decimals. List 3, on base percentage. Then you're going to hit Stat Calc. Number 4, linear regression. You have 2 equations. So for the first one, list 1 is X. List 3 is Y. The second one, list 2 is X. List 3 is Y. Those are both of your predicted linear regression equations. Then plug that batting average in. That's how many runs they should score. Plug that on base percentage in. That's how many runs they should score. All right. Folks, this next one here, I actually have this in. So explanatory variable, that is the X. So in list 1, you are going to see, so go hit Stats and Edit. In list 1 goes the GPA, in list 2 goes the ACT score. When you're done with that, you are going to hit Stats, go over to Calc, linear regression. Yours is a little different than mine. It's going to ask you what's the X, what's the Y. Mine kind of assumes list 1's X, list 2 is the Y, so I hit Enter, and it gives me that equation. A is the slope, B is the Y-intercept, and I have my R value, which is exactly what we see right here. It's a very strong correlation between GPA and ACT for this particular data. 3.61 GPA, plug that in. That's their predicted score, 28.13. They actually got a 31, so they overperformed. All right, if a student has a 3.37 and earned a 25 on the ACT, do they over or underperform? We'll put their GPA in for X, find their predicted score, and they underperformed because they had a negative residual. They underperformed, and the negative residual will be bad in this case. And running times, if you want to run faster, a negative residual is better. So they underperformed by like just over 1. Folks, central limit theorem, I will give you that. X bar is the mean. You'll know what the central limit theorem is, even if this question said normal distribution, which it doesn't. Let's say sample size, and it says you want a mean. You want to have a sample mean of whatever. All right? So figure out what X bar is. Do 495 divided by 50 to find the average time a jet is going to spend taxiing and taking off. All right, so X bar minus mu over standard deviation divided by the square root of your sample size. I would round that standard error, which is the square root of your sample size, to the nearest 1,000, 3 decimal places. I want to be less than that, so I just, whatever my z-score is, I keep it. Here, folks, I'm going to have the opposite z-score, and I want to be bigger than that, so notice how my answers are the same, but the true area left of that z-score of negative 0.26 was this, so if I want to figure out what is in between those two, means I'm going to subtract those two. I'm not going to get 0. I'm going to subtract 6026 and 3974. All right, male heights are normally distributed with a mean of that, standard deviation at. What's the probability of random sample of 25 males will have a mean height of at least 70? I've got to use central limit theorem there because I have a sample size and a mean height. Or a mean sample, average mean. I'm trying to evaluate there. All right, there's my z-score. I want to be bigger than that, so I got to do 1 minus that area to the left of my z-score. Next one here, what is the probability of that a random sample of 25 males will have a mean height of at most 67.5 inches? At most means less than or equal to that, so I keep that area to the left of that z-score, which is not much. And what's the probability that I will be between 68 and 70.5? I find both those z-scores. All right, z-score, area to the left of the z-score. Z-score, area to the left of the z-score. And I subtract this and this. 97% chance. The average of my heights for those males between 68 and 70.5 inches. Okay. 2 more with that. X bar is 4.7. Sample size is 100. Subtract 4.7 and 4.9. Z-score of that. I want to be less than that, so I do keep the area to the left of my z-score there. Again, you're again looking in here. All right. 5.05 minus 4.9. I want to be greater than that, so I subtract this area to the left of my z-score from 1. And lastly, let's take a look. 200 values, that's your sample size. Standard deviation is given. Population mean of 514, so in between 500 and 528. Notice they're both 14 away from average, so I will get opposite z-scores. All right, and I subtract both of those areas to the left of those z-scores to get 93.12. What's the probability that